Thank you very much, and once again, good morning, everyone, and thank you, Hugo, for the invitation. It's hopefully you can hear me well.
Okay. Yes.
All right, so let me just share my screen. It will be this one. Right, can you see the presentation now?
Yes.
Okay, I can see on the big screen behind you also that it's online. Okay, so a few things about myself. I am based in Warsaw. My name is Piotr Strzelecki. I work for Trimble Geospatial as a field application engineer for I think now it's like 13 years already. So quite a long time in Trimble. And today we meet together just to talk a little bit about the reality capture portfolio, how we call it in Trimble. So that's the scanners. And the agenda that I prepared for today is to show you and tell you a few things about the hardware itself. But you know, hardware is not the full thing. There is also software behind, so I wanted to cover a little bit software things. Some highlights about each of the scanners and software itself, and then talk a little bit about the applications and show you a few pictures of our customers really doing jobs with our scanners. I think sometimes one picture tells more than 1,000 words, so that would be hopefully interesting for you. And in the end, also a time for some questions that you might have. So, and Hugo, if I speak too long, if my time is limited, let me know, because I tend to speak sometimes too much than originally planned.
I will start showing you.
Do this after 5 slides and we are gone. Anyway, okay, let's get started with the portfolio itself. So I wanted to talk about the hardware, but also our field solutions for scanners with the tablet and with field software, and then tell you also a little bit about our office solutions, because what we do in Trimble, we do not sell and we do not deliver only hardware. We want to deliver an easy-to-use workflow to the end customer from field to finish, basically. So it's not just the box with the product, but it's the whole process behind and the whole solution. That's why software for us, the field software and the office software, it's an important part of the product itself as well. I'm not really a huge fan of technical specs, but I thought that it might be interesting to have a look on the numbers as well. In the scanners portfolio, we basically have 4 products, which is Trimble X7, Trimble X9, X12, and the SX12. The first 3, X7, X9, X12, they follow the, I would say, a terrestrial scanning workflow, and the SX12, this is our scanning total station, which actually follows the, I would say, a land surveying workflow, together with a land surveying field software. So if you look on the specs for the scanners, the X7 would be like an entry-level scanner, X9 a medium tier, X12 is a high-end, high accuracy and most advanced terrestrial scanner that we have, and the SX12, which is something completely unique, which combines both total station and scanner. So for the specs itself, I suppose Hugo later on can cover the numbers, but just wanted to give you a quick look on the portfolio with the numbers. So hardware itself, the X7 as an entry level in our portfolio, this is a extremely easy to use product. when we launched this, we wanted to have a scanner that actually anyone with even nearly no knowledge about scanning could just go out and do some scanning. So when we wanted to launch this product, we wanted to eliminate the big issue with the scanning, which is called the annual maintenance. Like if you look on the competition products, you will notice that you purchase the product, and then every year, basically, you have to send it back to a service center, which basically takes a couple of weeks to have the scanner calibrated back and have it in the field again. So with the X7, you don't have this need at all. So there is actually no maintenance cost after you purchase the product when it comes to calibration. You just buy it, and then you go into the field, and the system itself does the field calibration every time it starts and every few stations. So there is no calibration in service needed. We have with this scanner laser pointer that makes it possible to georeference your scans to a real world. This is a self-leveling scanner, and a very important thing from this scanner and from our off-field software is that we have full scan registration in the field. This is not a pre-registration, this is not something like registration, this is a full registration in the field, full colorization in the field, and what you actually get out of the scanner is a full point cloud directly from the field software. So if you want to output this to a third-party scanning, you don't even need any processing in the office with our software. Just take the field software and you get the product directly from the field. After launching the X7, we decided that we need also a mid-tier scanner, and we launched like a let's say an older brother of X7, which is X9. And X9 has all the same features like the X7, plus on top, it also has higher sensitivity on difficult surfaces without sacrificing the speed. The range of the scanner, the accuracy of the scanner is improved. And the auto calibration that we implemented in the X9 is higher and faster. So just a few examples of what the X9 can do. We have a high sensitivity mode with all scans. With high sensitivity, actually, I mean that you know, there are some surfaces like high reflectance surfaces or dark surfaces that actually are difficult to scan. So with X9, we have introduced the high sensitivity for all scans. And what you actually see in this picture is the view of our field software. This is actually how our field software looks on the tablet. So basically, you just start scan. And this is actually a nice area to scan with a scanner because that's a brewery. So you can not only scan, but only you can do some testing after. And when you scan with the X9, what you can see in this picture is the red dots is actually the visibility of the elements that were not scanned. Everything else in gray is actually perfectly scanned. And these objects, if you are familiar with scanning, like this shiny high reflectance, it's difficult to scan, but with X9 we completely eliminated this issue. There are some elements over here, maybe, which is like exactly in front of the scanner. The scanner is standing here. So you see some elements here on the left, on the right side, right? But here you see that the angle is very, very wide. so it's difficult for a laser to come back and to get reflected back to the scanner. Also, field calibration. If you look on this short graph, what we do, we basically do a field calibration for the scanner on the first few stations, which takes like 30 seconds maybe. And then later on any other stations, we just check up if the temperature is okay. And then we just do a very, very short check, and there is no need to do a field calibration on every single station. Just, I think it's like every 15 stations that we do a the full field calibration again. And wow, yeah, when I'm talking about the field calibration, for some applications, when you do it, you can actually run the report of a field calibration from a field software, and you see exactly step by step in a PDF format, then the system has been calibrated. So I have seen some customers, especially for forensics, that they have to prove that the unit is okay during the checks, during the measurements. So what some customers do, they actually do the calibration before they start the job. They run a report, then they do the job, and when they are closing the job, they are doing the field calibration again in the end and run a report again. So it's a kind of a proof that if I did it before and at the end, everything what happened in between should be also within the specs of the system. Self-leveling for X7 and X9 scanners is that there is a wide range compensator inside of both units. So you can just preliminary set up the instrument in the field, and then you will have like three diodes, I mean three colors of the diodes on the bottom of the instrument, explaining if the leg should be moved up or moved down. So the green, it means it's okay, blue is too low, red is too high, and just have it green and then you are ready to go. With the pointer, with the laser pointer, we basically use it for georeferencing to points measured, for example, with the total station or with the GNSS, in case you would like to georeference scans to real coordinates. And we do it with phase 1 and phase 2 measurements, and then just scan the target, just an example here, and then run a georeferencing in the field. Okay, so again, with georeferencing, you don't have to come back to office and do it in the office. Everything goes out exactly from the field. When it comes to scan times, we have, let's say, 3 modes, which is indoor, standard, and high speed mode with the ranges as given here, 30 meters for indoor, 150 for standard, and 120 for high speed. So if you look on the duration of the scan, they are really, really short. The tops is like 6 minutes, but this is with a high speed and sometimes rarely used. What I noticed in the field that the customers just do a standard setup and then just do a little bit more stations. This is actually faster to do more stations than do the duration in the maximum time setup. Then you have some numbers for spacing here on 35, 10, 35, and 50 meters, and the number of points you get out of X9. So I really wanted to put it in this way instead of just saying that this is 1 million points per second. That basically means not a lot, but if you see how it looks on the different ranges, then you get the idea more on how the numbers look like. So when we now move to the X12, this is the high-end scanner in our portfolio. It is the fastest, most accurate, and also the longest range compared to X7 and X9. Very accurate, very low noise when it comes to cloud points data, and also very good 50 megapixel cameras that we have on this scanner with LED illuminations, so you can even work in dark places and illuminate the photos that you are taking with the scanner. But the workflow that we have with the X12 is exactly the same. We have the same field software for X7, X9, and for the X12. All of the scanners come with 2 years warranty, and the X12 is IP54, but I think X7, X9 is IP55 with also lower temperature ranges. So I mean that you can even work with X7 and X9 with low temperature ranges compared to other scanners. And a few words about the SX12. So we wanted to have a total station and the scanner in a one product. That's why we launched the SX12. And this is a survey grade instrument. This is a 1 second instrument, total station, that follows total station, follows land surveying workflow. The range of the scanner here is 600 meters. We also have here the green laser pointer, which is visible, which has a size of 3 millimeters at 50 meters. And I would say that this scanner would be mainly used for applications related more to land surveying, like tunneling, roads, mines, and constructions that also, let's say, involve larger projects that we want to have a map and we want to have a point cloud within the land surveying jobs. So just a few photos of the SX12 applications. I'm not sure if you can see this on your screen, but actually SX12 is this few pixels here. And we are scanning the construction site here. Wind farms. This is a tunneling application. And okay, so software. I wanted to tell you a few things about the field software and 2 pieces of office software that we have. The perspective, this is our field software that we use for X7, X9, and X12 scanners, which is basically really easy to use, and you can basically have no training, just go outside, press start scan, and you're ready to go. Trimble RealWorks and Trimble Business Center, these are 2 office pieces of software. RealWorks mainly used for, how to say it correctly, terrestrial scanning applications and lower, smaller scale projects, I would say, than where you are interested in modeling, that you are interested in classification, that you are interested in mesh, this kind of applications, and also combining photos with the point cloud. Whereas Trimble Business Center mainly focused on land surveying jobs where you can add the scanning data. Perspective works in 3D, so there is full 3D visualization of the data that we have scanned. It has an automated full registration in the field, colorization and exports that we deliver directly from perspective. So, for example, if you would like to have an export directly to Revit or to Autodesk or with other formats like LAS, and you would like just to have the point cloud, you just take perspective, colorize, georeference, and then export to a dedicated format directly from field software. For this instance, no Office software actually is needed. It has the possibilities to add the annotations, labels, and measurements. We have also option of area scan. So the area scan is like, let me give you an example. You are scanning a very large building, but there is a need to scan a smaller part of the building, like a piece of facade or some sculptures on the building. Then you can just put very high accuracy area scan on a specific elements of the building to increase the point cloud visibility. So what I mean is that if you are doing this, you don't have to do a full dome scan of the building in a very high accuracy and spend a lot of time on this, but you just need to do a small pieces where the high accuracy is actually needed. Georeferencing, I mentioned this already, and the diagnostics and calibration reports directly when you are in the field. RealWorks, that's the solution that actually supports, it's a scanner agnostic, I would say. You can virtually work with any scanner and point cloud. It has the automatic registration scanning and survey workflows. It has orthophoto capabilities, things like floor flatness analysis, which is shown actually here, that you can generate a heat map and a report of the floor flatness. We have plenty of 3D inspections there that you can compare point cloud to the model, or point cloud to a surface, or point cloud to a point cloud. And this example here is actually the tunneling inspection. We have also classification here that you can automatically generate the classification of the point cloud. I mean the ground, the low vegetation, high vegetation, buildings, signs and poles and power lines, both for indoor and outdoor. Additionally, we have the modeling options there. What I mean is that based on the point cloud, like shown in this picture here, you can actually model, for example, pipes or handrails or stairs or cages or wire frames. This all can be modeled inside Trimble RealWorks, and then, if needed, you may even have a direct connection to AutoCAD, Revit, or SketchUp, and these things, what you draw, what you create in RealWorks, can be automatically sent to a software like Revit, which is opened at the same time on your computer. So this is I would say, like a real-time integration with other pieces of software. This software also has a project sharing, which is shown like here, that in case you would like to present your customer something from the project, we have that integrated as well. That's called the publisher. Storage tanks. One more thing I would like to mention is that we also have a special module in RealWorks for a specific application, which is storage tanks. We can do both vertical and horizontal storage tanks, and actually measure the roundness of the tank and the verticality of the tank, and a second compartment of the tank as well, and run directly from the software the reports in a really smooth workflow and deliver this to the customers. On the other hand, TBC, Trimble Business Center, this integrates the survey and construction worlds. And in Trimble, this is like our hub for all type of deliverables and all type of data that you may put into the software. So in Trimble Business Center, you may take the data from the scanner. You may take the data from GNSS, take the data from Total Station, or even from the GIS, or even from mobile mapping, and then do the outputs to either a cloud or a third-party software. So this is our hub to integrate all types of data that comes into the survey world. What it especially can do for laser scanning? Well, TBC, first of all, is designed to work in coordinate system. So whatever you put in TBC will be properly scaled, will have a proper scale factor also applied to your point cloud. I mean the scale factor coming from your coordinate system. There is classification. We also have automatic features extraction here, orthophoto creation, inspections. You can measure surfaces, and there's plenty of exports and reports depending on what you would like to do, but many more. A little bit here. So we have also special modules for tunneling and roading in TBC. That what I mean is that you can take the point cloud of the tunnel and compare it with the model that you designed in Trimble Business Center, the model of the tunnel, and then run a specific report comparing the point cloud to the tunnel or the point cloud to the point cloud. So for all these applications, like when you are shooting the excavations in the tunnel, that you have the overbreak and underbreak, this is visible in TBC, and you can run reports directly. Same for corridors creation. In TBC, you can actually create roads, corridors, and compare them to the surface, and then export to Trimble Access for measurements. A few things additional in TBC, in case something cannot be scanned or was not scanned, but you get the photos, you can still do a virtual measurements based on the photos, like in this example here. So this is the photo taken from the scanner, and then with virtual measurement, I can actually measure points from photos. We have volumes calculation. We have automated or semi-automated feature extractions, like trees, signs, line markings, cracks on the pavements, automated curve extraction as well, and lines based on the intensity. This is all supported with the deep learning technology. So we actually have feed the engine with a lot of data and teach it how to use, how to be more efficient. Creation of maps and symbols based on the extraction, and just an example of reporting of tunneling here. And last but not least is the mobile mapping data. So on top of the scanning, total stations, GIS, and others, you can also have the mobile mapping data inside TBC. Okay, so now a little bit about the applications. Perspective, Perspective, which is our field software. The 3 A's, auto full registration, auto calibration, auto leveling. In field registration, that everything happens actually in the field, with the accuracy of 3 seconds instrument. Laser pointer, high sensitivity. And actually, one thing I wanted to mention is that the data is stored on the SD card, which is in the scanner, and also sent directly to the field software. But you have the redundancy. So if something happens with the project of your on your tablet, you still have the raw data on the SD card inside the scanner. So there is a backup. It's really easy to use. And you have a few ways of working with the X7 and X9. You can have the tablet to work with perspective. You can have your phone and just use the special version of the application to work on your phone. You may also work with just one button. The X7 and X9, they have one button which when you press, they start scanning with the last use setup. So you don't really need any tablet at all if you don't need to verify what happens in the field. And we also have a cable connection to send data to the computer with the cable. What I mentioned before is that they work in low temperatures. I mean, -20 for scanners is really, really good. If you look on what happens on the market with the scanning solutions, they tend to not work with low temperatures and they tend to not work with high temperatures. This is not the case for X7 and X9. They both work with pretty low and pretty high temperatures. And don't forget, you don't have to send it every year to service for verification. SX12, this follows the land surveying ecosystem, which we have with our Trimble Access field software used for land surveying operations, and the data transfer either to TBC or Trimble RealWorks. So I wanted now to show you a few slides with the pictures about these industries and with our actually customers that use these solutions in real life. And I will start with a small picture where someone really wanted to measure the milk tanks in the field, which I found particularly interesting. I was really surprised about this one. So a standard thing, building construction, right? So that you can combine the GNSS measurements with your scanner and then just go and scan different things and go out with the point cloud and create building plans, for example. This is the SX12 example of construction inspection that we actually have the visibility of the augmented reality in Access field software. And this can be scanned. So this element is scanned. The red color is a point cloud. And then based on the scan, I can actually compare the point cloud to an IFC model, like in this example, and get a heat map of the comparison. So where I can see if the build elements are well placed according to the model. All types of industrial surveys like engineering rooms or pipe rooms or facilities, also fabrication workflows, where we can again scan the elements like shown here and then compare the point cloud to the model or stake the elements of the model. Wrong slide. Tank inspections. So these are our customers that actually work on various type of tank inspection, and they use either SX12 for this or this terrestrial scanners like X7 or X9. This is what you actually get from the Office software workflow. Industrial surveys. So we can just scan something and then model the elements like shown here. So this is all modeled here in Trimble Reworks. Well, civil infrastructures, naval and automotive, aerospace, railway. I just wanted to mention here that for shipyards, shipbuilding scanners are very often used. And with shipbuilding and ship inspection, you have something like ballast tanks that also have to be verified and checked from time to time. That we also use our scanners on this. Tunnels and mines, this is mainly the SX12 application that just scan and compare with the model. Volumes inspection, that one was really interesting. It was like X7 mounted on a special drone to go inside the pipe and scan it. And the other one was the crack inspection. It's almost like a landslide here. Shown. Actually, this is, yeah. So this is the top, and it's what also happened. Cultural heritage, and then out of the facade scanned, you can get the drawing. Forensics applications with our specific software for forensics. We also we can reconstruct the site, the police site, crime site. We also have a bullet trajectory recognition in our software. And Hugo, do I still have like 5 minutes, maybe?
Yeah, I think it's fine.
Okay, so just a very short example of the use, like from field to finish with a few photos. So there we had a project just to measure a building, an old building which needed a reconstruction. So what we did first, we had to measure some GNSS points for georeferencing of the point clouds. So we used the R12i for this. And then based on the measured points in XYZ, we use the scanner to scan the road and georeference the road and the point cloud to the measured points. So there we continued to scan the outside of the building, and then the backyard, and then inside the building, and really inside the building, like this is the basement here, and so the diodes blinking in blue, it means that it's okay for scanning. Then we also did some scans like in the windows to have a good comparison in between the outside and the inside, to have a nice cloud fitting and compare everything. I mean to build one comprehensive point cloud from all of the scans. And then what we did, we put everything to TBC, Trimble Business Center. This is a colorized point cloud. Then this is the view of the 3D. We did the auto classification in Trimble Business Center, so you can see the ground in brown, the trees, the high vegetation in green, buildings in blue, some lamps and signs in red. So this is an automated feature in TBC that you can automatically classify regions. Based on this, we did also some automated or semi-automated features extractions like trees. We also have curb and gutter detection, automatic in TBC. Additionally, if something needs a specific point, you can just click on the photo and it will be measured based on the point cloud. And then generated map. Additionally, wanted to measure the buildings. A module that we have from our partner Fernando Calvo here, that really simplifies and speed ups the way to do the building plans, right? So this is shown here like a cutting plane of the point cloud, and then just based on the like a pre-setup tools for buildings with easy setup, you can automatically, or not automatically, but very fast create the floor plans. So this is what we got from the project, and we also can measure the perimeters and volumes of each of the rooms. And then this is a kind, I would say, a kind of map in the end that you can extract from Trimble Business Center. So that actually concludes what I wanted to say. So if you have some questions, please
yes,
let me know.
Yeah, very good. Thank you, Piotr. I will ask Tartu konkreetselt. Eesti keeles ei ole. Nüüd ta kuskil oli vist. Yeah, Piotr, you made very clear presentation, so no questions. So at least not that's now. So we have to take some beers, and after that will come questions too.
Okay.
Good.
Thank you very much then.
Thank you for your time, and see you next time. Yeah.
See you next time. Have a good day today. Yeah. And well, what can I say? The Christmas is coming, so Merry Christmas to you all, guys. Yeah, I have already locked the door, and everybody has to buy something before some presents before they can leave. It's good. Yes. Yeah, thank we count on that. Thank you, Hugo. Yeah. Okay. Yes. Have a good day. Yeah. Bye. Bye. Bye.